Alright, solving problem 4 is really simple. You just have to find the tension in the slanted chord. That's this chord right here. So let's go ahead and think of this object as its own system. So we'll draw a system, and you can call it whatever you want. I'll just call it ball. And think about the forces acting on the system. So obviously it's interacting with this rope and that rope. So let's call this rope 1 and that rope 2. And there's going to be some tension in that rope T1, and then some tension in this rope, which we will call T2. Judgment Day. Now this 30 degrees is also 30 degrees here, which if that's easy for you, it's fine. And what we're going to do is we're going to take that 30 degrees and turn this second tension into an x and a y component. So this will be T2x and this will be T2y. Then the third interaction that we aren't thinking about is the interaction of this mass with the mass of the Earth. Now it already tells us what this is. The weight force is 100 newtons. So we can just draw that down. And if you want to call it W, you can. Or if you just want to label it as 100 newtons, that's also fine. Okay, then you can think about summing up the y forces. There's nothing in this problem to tell you that it's accelerating, and you can assume that these y forces add up to 0. Now there's only two y forces. There is this T2y and then the weight force down. So if we want to say that they are equal, that's fine. And this would be positive, so you could write it T2y minus 100 newtons equals 0. Or another way of thinking about that is T2y equals 100 newtons. So that's what the vertical component of this tension is, but we want to know what the actual tension in the rope is. So I need to remember that T2y, the vertical part of the tension, is actually the magnitude of the tension times sine of theta, because this angle is opposite of the vertical component. And theta is 30 degrees. So if you want to write T sine 30, that's also fine. Okay, so you plug this value in and you realize that T2, the tension in the second row. So you say T2 sine 30 equals 100 newtons. And then you divide both sides by 30 and you realize that T2 is 100 newtons divided by sine 30, which actually ends up being about 200 newtons. So that is the second tension in this rope right here, which is answer D.